The next step that we are going to do is the hyperparameter tuning. See, so there are two methods for doing hyperparameter tuning. One is grid search CV and other is randomized search CV. In our case, see, randomized search CV is generally faster. So that is why we are going to use that. Randomized search CV. So first we have to assign the hyperparameters in form of a dictionary. Then we have to fit the model, and then we have to check the best parameters. Okay. So here we will select it again now from sklearn.model selection, import randomized search CV. Now this is done. Now we have to give the parameters. So n_estimators, this will be int x for x in np dot line space start equals to 100, stop equals to 1200, num equals to 12. Perhaps you forgot a comma. This bracket is wrong actually. It should be normal curly brackets. Okay, so n_estimators I have put in. Now max features, this will be auto, comma, and sqrt. Max underscore depth, this is int of x in np dot line space 5, 30, num equal to 6. Now minimum samples split, this I will give some random values 2, 5, 10, 15, 100, and minimum samples leaf, this also I will give some values 1, 2, 5 and 10. Okay, now we have to make a dictionary. What is the problem? Int x for x in. Now it should be fine, right? Okay, now we will put it into a form of dictionary. So random underscore grid, here we will make the dictionary. n_estimators, basically this we are going to copy and paste, comma, max underscore features, here we will put max features. Then we have max depth, Next we have minimum sample split, and next we have minimum samples leaf. Okay, so our dictionary is also ready now. Now we have to I'll show you the next step now. rf underscore random, this is equals to randomized search CV. Okay, so you have to apply the randomized search CV. Where? On what you are going to apply? On the regression tree. Which is the object of regression tree? We have made it by the name of RF. So estimator equal to RF, the model that we had fitted in the beginning. Now what are the parameters? So param underscore distributions. This will be the grid that we have created. This is done. Next we have to give the scoring. How the scoring will be done? So I will put negative mean squared error. Next I have to put number of iterations, that is 10. I will put CV equals to 5, number of cross validations, verbose equals to 2. We have to give a random state and n underscore jobs equals to 1. So our randomized search CV object is ready. Now we have to fit our data into this. So rf underscore random dot fit. What we have to fit? Train only, comma y underscore train. Now the fitting process will start. There seems to be some error here. ERR. Okay, so it has started. It will take some time here, so we don't have any choice, we'll have to wait for it. See, after this is done, we have to check for the best parameters. So the syntax for it, that is rf underscore random, basically the object dot best underscore params underscore. So this will give us the best parameters. Next we will do the prediction. So we will use rf underscore random dot predict. What you want to predict? Test values. Okay, we are not executing it right now, we are just writing the code. Once this cell is completed, once the randomized search CV is fitted, the data is fitted, after that I will be executing this code. So once the prediction is done, I have to evaluate the model. So to evaluate the model, I need the mean squared error. I will do mean squared error. Mean squared error of what it will be done? It will done for test value and the prediction value. With this we will get the mean squared error. To get the RMSE, we have to do the square root. Square root we cannot do directly, we have to do np dot square root of what? This one only. So here we will put a variable MSE and here we will just write MSE. Okay, this is still continuing, it is still ongoing. So with this we will get an evaluation of our model. After this we will do what we will see, how we can save the model to reuse it again. Saving the model so as that it can be reused again. While this is going on, that means that the cell is still going, it is still working. Okay, let us proceed. We will see the syntax of how to do it. First we have to import pickle. Then we have to define a file name, file equals to open. We have to give the name flight what random forest dot pkl comma wb, and now we have to dump it, pickle dot dump rf comma file. This is the object, this is being dumped into this file. Now we have to open the model. Model equals to open. What you have to open? This one only. This is the one that you have to open. Flight will directly copy it from here. Okay, pkl comma, this time it will be rb since we are reading it. This wb and rb also has to be in the quotes. Now okay, it seems we are about to be done. Forest equals to pickle dot load model. Done. Now we have to make the prediction on our data set. So y underscore prediction underscore pkl, this is equals to forest dot predict. What we have to predict? Test value x underscore test, and after this we will check the R2 score. So R2 score of y underscore test and y underscore pred underscore pkl. Let us see. So let us look at this. Cell execution has been completed, right? So when we execute this cell, we get the best parameters, n underscore estimators, this minimum sample split, minimum sample leaf, maximum features and maximum depth. Now we will do the prediction. Okay, prediction has been done. Here we can evaluate the model. We will get the RMSE value. I will show the RMSE value also. Okay, so the RMSE value is 1998. Now we will save this model. See, first code is executed, second code is executed. When we check the R2 score, there seem okay, we will not put R2 score, we will simply put score. Sorry, rf dot score. Okay, let us just check the RMSE only. See, we get the RMSE value 1895. So this was an implementation, it was an example of how one project can be implemented. We used some tools, we did the data cleaning also, we fitted the model, we loaded the model, we did the hyperparameter tuning. So I do hope that you got to learn a lot from this videos, from this session. If you have any advices or if any comments, please do let us know. We will certainly incorporate it in our next videos. Thank you.